Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for December 29th of 2025 is titled M1, the Crab Nebula. So what do we see here? Well, here we see the example of what happens when a star explodes. Now, this would be a massive star at the end of its life, something 20, 30, 50 times the mass of our own sun. And it will build up an unstable core of iron. Essentially, stars produce energy through what is known as nuclear fusion. They fuse lighter elements into heavier ones to produce energy. They start out fusing hydrogen into helium, and that powers a star for most of its life. When the hydrogen is used up, many stars will be able to fuse helium into carbon, and then so on up to iron. However, iron is the most tightly bound nucleus, and you cannot get any energy out of fusing iron atoms together. So once you build up a core of iron, the pressure continues to build, the temperature continues to build, and then iron starts to fuse, but it starts sucking energy out of the star, and it then implodes. The whole core collapses, and then leaves behind in the resulting rebound an object like we see today. So this was an object that was seen to explode here on Earth almost 1,000 years ago, back in 1054, and was noted by various early Chinese astronomers on their star charts. And when we look to those areas today, we find the Crab Nebula, and measuring expansion rates of the Crab Nebula tie it back into that time, that it exploded about 1,000 years ago. And you can do that by measuring the expansion of various knots of material within the gases, which are constantly expanding because of this massive explosion. In fact, in that 1,000 years, it has expanded to be light years across, and has greatly increased its size from an individual star-sized object to something much larger. Now, at the center of this is what is known as the Crab pulsar, a rapidly spinning neutron star. That is what occurs in the explosion when electrons are pushed into the nucleus. The electrons and protons fuse together, forming neutrons, and essentially you have a big ball of neutrons there. And because of the conservation of angular momentum, it spins very fast. In fact, the Crab pulsar spins 30 times a second and is whipping around. And the only thing that could spin that fast without ripping itself apart is an extremely dense neutron star. So it's something that has the mass of maybe a couple suns, but is the size of a city. So it has really been compacted. All the space within an atom has been compacted out, and we're left with just essentially nuclear material, just material from the nucleus of an atom. Now, what will continue to happen to this? Well, it will continue to expand over time, and eventually the material will dissipate and will head off, become part of the interstellar medium, and become seed material for future generations of stars. So it's quite possible that heavier elements that make up our Earth and you and me were once in a supernova explosion many billions of years ago, before our sun even formed, and then became incorporated into that cloud of gas and dust that formed our sun and eventually formed us. So that was our picture of the day for December 29th of 2025. It was titled M1, the Crab Nebula. We'll be back again tomorrow for the next picture, previewed to be Artificial Comet. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.